Hi, now that we have learned all the theory of linear regression model, now is the time to implement all this knowledge to build our first full-blown linear regression model with multiple independent variables. In this implementation, we will be following these steps: importing libraries and the dataset, checking for multicollinearity and removing it, scaling the dataset, creating test and train partitions, implementing the linear regression model using scikit-learn, generating predictions over the test set, evaluating the model, plotting the residuals, verifying the assumptions of linear regression, visualizing the coefficients to interpret the model results. Now, an important thing to note is that some of the assumptions of linear regression need to be checked before the model implementations, such as multicollinearity. This is because we do not want the correlation between the independent variables in our model. On the other hand, we check some assumptions like homoscedasticity, that is constant variance of the error terms and the normal distribution of the error terms after the model implementation. As to check these assumptions, we require the residuals, which can only be obtained after the model has been built. So let's dive into implementing linear regression. We start by importing the necessary numpy, pandas and matplotlib.pyplot libraries as always. Next, we are importing the dataset transformed_housing_data2.csv as data with the help of pandas.read_csv function. Now, if you remember, transformed_housing_data2.csv was formed after performing the following steps: exploring the target and the independent variables, treating the outliers and missing values in independent and target variables, transforming the categorical variables into numerical variables using dummy encoding. Therefore, the data we are using has already been through the basic preprocessing. So, let's look at the data using data.head function. This is the dataset that we have cleaned, imputed, and transformed using the suitable preprocessing methods which you have seen previously in this training. Now, our first step should be to scale the dataset using the standard scaler. In this cell, we first separate the target variable as y. Then, we use the scaler, that is an instance of standard scaler, to scale all the independent variables and store it in x. Once we have scaled the independent variable, we again convert it into pandas data frame for easy manipulation. Now that we have scaled the dataset, our first task before implementing the linear regression is to check for the correlation among the independent variables. We already know how to check this using the x.cor function, which gives us the correlation between every possible pair of variables in our dataset. So let's do this and look at the results. The result we are looking at is humongous. This is because we have 30 columns and correlation is between all the possible pairs. Therefore, there are total 900 correlation values in this output. It would be very tedious to work through all these values and find the correlation above 0.5 manually. So, is there any easier way to extract the pair of independent variables which have high correlation with each other? No, there is no direct method or a function to do that, but we can define our own function to get a rough idea. Our method will check every row and column in the correlation table above and store the pair of variables between whom the correlation is greater than 0.5. For this, I will use the x.cor function again, but this time I am storing a result in the variable k. Now the next line which we are writing is quite interesting. It is called a list comprehension and allows us to write some loops and simple nested loops to form a list in a single line. So let's break it down step by step. It can be divided into the following parts using the syntax result equal to element of final list into how to take different values into condition to store the final element. We first look at the right hand side, which is the main part. The red box part represents the single element of the final list. The final list is nothing but the collection of pairs of independent variables. You can notice that there are two elements with I and j in string format as a pair requires two independent variables. In the green box, we have the range of values that I and j can take. In this case, both of them range over the values in k columns. Now can you tell why we use the same range for both I and j? Because in the correlation table, we have the independent variable names along the rows as well as columns. So our variables I and j will take every possible combination of the independent variables. Now the third part in the blue box is the condition to store the part of independent variables into the final list. The condition says only store the pair of independent variables I and j, combination of which has a correlation above 0.5 in magnitude and the I is not equal. So to summarize, in the correlation table, we are going through every pair of column and row label and storing that pair if the absolute value of the correlation for that pair is greater than 0.5. Let's go through the first couple of iterations to understand what is happening. As the variable I is traversing through the columns, it will take the first value as number of bedrooms. Similarly, j variable will move along the rows and take the first value as number of bedrooms. But as we have mentioned a condition in our list comprehension, I is not equal to j. The correlation stored in the corresponding row and column is not stored. In the next iteration, the column value remains the same and the row value j is updated to number of bathrooms. And as the corresponding correlation is greater than 0.5, the list comprehension stores this column row pair, that is number of bedrooms and number of bathrooms, into the final result. And this way, the list comprehension traverses every possible element of the correlation data frame and returns a collection of pairs of independent variables with correlation magnitude greater than 0.5. So let's run this cell and observe the results. Now this looks like a lot, but luckily every pair is occurring twice. Say number of bathrooms, overall grade is also there, overall grade and number of bathrooms is also there. This is because combination of ij and ji will have the same correlation and hence both will appear. Now at the bottom, we have printed the number of pairs we have got, and its value is 32, of which only half the number, that is 16 pairs, are unique with correlation greater than 0.5. Now the next task would be to remove the variables from the pairs to avoid the multicollinearity, and that we would do in our next tutorial. See you there.